In this section, we are going to look at ERC20 tokens. Now, ERC20 tokens might sound very weird for you when you hear it for the first time, right? But what is this ERC20? Is nothing but Ethereum request for comments, right? So when you look at all of the token standards that we have in Ethereum, ERC20 is one of the most important, I would say, right? Because we have seen the differences between fungible tokens and non-fungible tokens and the utility tokens, etc., right? Most of the things that are created on Ethereum follows the fungible token standard called as ERC20, right? Because imagine the fungible tokens mean that you can exchange it without reduction in value with the other tokens. If you have 50,000 tokens, right, let's say British Airways tokens, and you want to transfer 20,000 tokens to the other person, it doesn't matter if you transfer the first 20% or the last 20%, right? So that is how this ERC20 token standard is gonna behave for us, right? This ERC20 means Ethereum request for comments, right? Ethereum request for comments. What does this Ethereum request for comments mean is that whenever you want to set a standard, you want to add a new feature into Ethereum, as a developer or as a enthusiast of Ethereum, you will create something called as EIP, that is Ethereum improvement proposal, right? This improvement proposal that you create will go to all of the nodes because it's a decentralized network, as we know, right? And these people will negotiate on that and change the features, add some more. All of these things will keep on happening, and at the end it will become a ERC standard. So these Ethereum improvement proposal can either be in the form of smart contracts, what should be done, security things at the protocol level. Any of this is available in the EIP, right? Now EIP, Ethereum improvement proposal, is going to convert into ERC standard, and ERC20, ERC721 just means the number at which this EIP was introduced. So these also started as EIPs only, and then it became ERC20 standards that are used by all of the people in the Ethereum network, right? So now that we have understood the background of what is this ERC meaning, right, we'll look at ERC20 in detail. Yeah. Now, ERC20 is a standard followed for creating fungible tokens, right? Fungible tokens. Why do we need standards in the real world? If you look at, yeah, if you take any food particle that you are buying, right, this food has to be going through a particular FSSAI or FDA or all of these standard bodies, right? And it should meet minimum criteria. Should not be expired, should not travel for so long, should not be kept under so many degrees of temperature, etc., right? So these are a few things that these standards talk about, yeah. And whatever follows these standards are known as standard tokens and will be accepted by the entire world. Now, if you create your own token, let's say something like blockchain token, okay, blockchain token. Now, this token, you want people to accept this as a standard token, and they want to exchange among themselves, trade among themselves, right? As we saw in ICO example, etc. You have to create a token which can be traded between people, etc., right? Now, the trading will happen in an exchange, right? Either in a fiat exchange or an altcoin exchange, as we have seen. Now, this exchange should be able to talk to the token, correct? So let's say I create token 1 and you create token 2, okay? And some person wants to transfer token 1 to token 2, convert it, right? So this he wants to do. Now the first person says, okay, the function is called as transfer, okay? And the second person has named the same transfer, right, but in a different name, same function in a different name. He is naming it send. So the exchange will not know what functionality is within transfer, what functionality is within send, right? Just to make it both in the same page, right? And to be spoken to by the exchange or any other party who is coming in, we need to have standard functions, okay? Standard functions and standard events, right? Along with standard variables, correct? So these standard functions, events and variables form the standard set by ERC20, which means nothing but if you are creating an ERC20 token, right, you have to follow a set of rules. What are these rules? What variables you have to create, what functions you have to create, what events has to be emitted, right? These are set by the standard. You just have to follow the rules and create your token. Only if you follow these rules and create all of this, it becomes an ERC20 token and will be accepted by all of the people. If you don't do, it is always possible to create a token without following the standards, right? But if you do that, then it will not be accepted by the exchanges for listing and all of these things, right? So that is the concept of ERC20 tokens. When we get into the code of it, I'll explain more about what each of the functions mean, right? So now I told you that ERC20 standard is going to have some set of variables, events and functions that are predefined. You know, the standard says this is what is mandatory for you to create a ERC20 token, correct? Now, what are those variables and functions? I have given on the screen, right? So this I have taken from the ERC20 official page by Ethereum itself. Yeah. Here they suggest that there should be three variables. One is the name of the token. Second is the symbol of the token. If you know, Bitcoin is known as BTC. Ethereum is known as ETH. Cardano is known as ADA. And Bitcoin Cash is known as BCH. You know, every crypto that is there on the market, the exchange, has a symbol of its own, right? In the exchange world, be it stock market or in the crypto world, people exchange only using symbols, right? So that is why we need a symbol for our token also. And comes decimals. So what is this decimal? A decimal says that can you transfer partial tokens to people, right? So the maximum is 18 decimals. Okay. So if you say, let's say 2 decimals, right? That means you will be able to send, let's say 124.25 tokens to someone. If you say 4 decimals, you will be able to send 124.2542 this tokens to someone, right? So this way, maximum is 18 decimals, right? You can say 100.1818181818. That many tokens. You can split your token into multiple parts if you give more decimals. If you give 0, you can only transfer whole numbers. You can either transfer 100 or 101 tokens, nothing in between, right? That is how this decimals is going to help also. Okay. Note that this is a string, and this is a unsigned integer, correct? Wonderful. Now, let's get into the functions and understand each of these functions, why it is used, what is the use of all of that, etc. Right? And then I'm going to fill out these functions. For now, you only see the function declarations, right? And we'll write out all of this and make it into a working ERC20 token itself. Okay, we'll do that for sure. Now, the first function is called as total supply. Okay. Whenever you create a token, just like we saw in ERC20 token creation also during fundamentals, you can create how many ever tokens you want, right? You can create 1,000,000 tokens, 10,000 tokens, 10 million tokens, anything, depending on your business use case. And you have to look at, okay, how many tokens are needed for the customers that I have, etc. Right? So based on inflation, all the economics concepts, you will create the total supply of the tokens. So this total supply is gonna return the total number of tokens that you have, right? So that is the use of this total supply function, which returns a unsigned integer 256, correct? Because the total number of tokens that you have only can be a positive number, right? This returns a unsigned integer 256. Then comes balance of. So token owner, I will send my address. If I give my address, it will return how many tokens that this person have, right? So this also returns an unsigned integer. So this says how many tokens does this person have, right? So if you give the address of any person, it's gonna give how many tokens he has. Next comes transfer. Okay, now transfer is from one person to the other, right? So if I call this function, I can give, let's say, John's name, right? John is another person, he has a receiver ID, the address, and I want to transfer, let's say, 1000 tokens from my account to his account, right? So I'll give his address and I'll give the number of tokens to transfer, and this is going to return a boolean which is return true or false, right? If it transfers properly, it is a true, otherwise it will false, right? Transfer helps in transferring from your account to another person, right? Transferring from your account to the other person. Okay, now comes the concept of approval, allowances, and transfer from. To understand this, we'll get into the theoretical portion of why that is used and why is it important, this transfer, allowance, and approval kind of things, right? So now let's say there is a company. Okay, there is a company called as A, right? Company A. Now there will be a CEO of this company, and probably there is a admin, right, who is in the company also. Yeah, now if you look at, CEO is the person who owns the money, who can spend the money, or who has complete authority over whatever amount is there. Let's say there are $50,000 in the company A's bank account, or let's say they have stored cash inside the drawer inside the company itself. Okay, this is there in the company premises, right? If the CEO wants, he can definitely take this money, spend it, because he is the person who can approve spending of this money, right? Now let's say the CEO is the person who can, who is the only person who can approve, but there is an admin also, right? Usually what happens is, let's say an Amazon parcel comes in, Amazon delivery comes to company A. Okay, we cannot expect the CEO to be always there in the company, right? Evening in late hours, or during weekends, or let's say during the daytime also he might be in a very important meeting, or might be traveling or something, right? When the Amazon delivery comes, and it's a COD based, cash on delivery based delivery, right? So in this case, can we expect the CEO to come, take let's say $100 from this 50K and give it to Amazon? We cannot expect the CEO to do that, right? That is why the CEO approves, right? Approves the admin, or gives an allowance to the admin, right? What does he say? He says, I am approving, okay, I am approving that you have, let's say the admin has authority to spend till, let's say, $1,000, okay, $1,000 allowance, right? $1,000 to spend from the company's vault, right? Whenever these kind of COD things or anything comes up, okay. So the CEO approves the admin that he has $1,000 allowance. Now what happens is, let's say this person admin has authority over this only for $1,000. Okay. Now when the Amazon delivery comes in, he doesn't need to wait for the CEO or get his approval, because he has been already approved for $1,000, right? He can just spend this $100 from the company vault to this Amazon delivery, and he can get the parcel. So you don't need to always depend on the CEO to get this, right? In the same way, okay, in the same way, there is an exchange, okay, there is an exchange. Let's say Binance is the exchange, and I am owning, Raghu owns, has 50,000 rupees or tokens, let's say, okay, 50K tokens I'm having, because we are in the tokens world. Let's talk about in token terms itself, right? I have 50k tokens. Now I am let's say saying in the exchange that wanna sell, okay, I wanna sell 1000 tokens out of this. Okay, 1000 tokens I wanna sell. Now this selling, okay, someone can come at 12 p.m. my time zone and I want to buy my tokens. Will I be able to be awake for 24/7 expecting that someone will buy and I can approve selling and things like that? That's not possible, right? Which means I cannot use the transfer function that's there in ERC 20. So transfer function is not there because if you look at the transfer function, I am the person who needs to transfer, right? I need to give receiver address and I need to give how many tokens I want to transfer. Only I can do that, right? Whenever I'm doing it in an exchange, we don't know. There might be 990 orders for this 1000 tokens. Each person getting one token, right? Will I be able to approve each and everything? That's not going to be possible by me, right? That's why I will give approval, okay? I will give approval to Binance, okay, to Binance of this 1000 tokens, right? This 1000 tokens. So whenever someone comes and buys from Binance, Binance will call a transfer from function, right? Transfer from function only if it has allowance, okay? Only if it is approval, it can transfer from my account to his account, okay? Seller to buyer, right? Automatically. When I say automatically, it doesn't mean it happens immediately, automatically, that way. It means that the seller does not need to approve this transfer, okay? It just goes, this is done by Binance, okay? So that has a separate function which can be called, and this transfer can happen without the involvement of the seller itself because he has approved already. Binance do it. Just like the CEO approved the admin, CEO does not need to be when the transaction happens, right? Seller has approved Binance, seller does not have to be there when Binance is sending it to the buyer, right? So that is how this approval, allowance and transfer from function come into picture, okay? Now go to this remix. You can see that the first thing is approve. What do you approve? You will approve that, okay, Binance can sell, let's say send 1000 tokens maximum from my account to the other person's account. So who is the delegate here? Binance. Remember, the exchange will be the delegate, or from now we'll call it the delegate itself, right? I am delegating my authority for 1000 tokens to the other party, right? And how many tokens I am approving, right? If it is 1000 tokens I want to delegate, then I'll say 1000 or I'll give some more. This also returns a boolean, right? So let me just write a comment saying used to delegate ownership of, not ownership, used to delegate authority to send tokens without my approval. Okay, makes sense? That is the approve function. So first I will approve Binance to spend my tokens. Second thing, you want to check the allowance. Okay, you will say how much has Raghu allowed Binance to send. That checking has to be done. So owner is myself, delegate is Binance, and I will say owner has delegated how much to Binance. So it will give 1000, right? How much has the owner delegated or approved, right, to the delegate? Yeah, this will be checked and you can get a unsigned integer for if you call this function, okay, allowance. Then comes transfer from, okay. This is the function that Binance will use if it wants to send money from the seller to the buyer's account without the approval of the buyer or the seller, no, sorry, right? So unlike transfer, which has only one receiver, because the sender will be message.sender, me, right? So here it will be the owner, okay, that's myself, buyer, whoever is buying my tokens, and the number of tokens, correct? So this is how Binance will transfer from my account to the buyer's account the number of tokens required, and it will give a boolean response, right? Used by exchanges to send money from owner to buyer. right? I hope that explains the usage of all of these functions that we have here, right? I hope that example of CEO and admin is memorable, right? And you can always go back to that example, make notes of it, and refresh whenever you want to know about why this is used and things, right? Now, one of the common misconceptions in the blockchain world, whenever I hear people talking about it or read an article about ERC20, they talk about this approve, allowance, and transfer from being automated payments kind of a thing, like an EMI that you pay, right? Many of the examples state that if you allow the bank, to get money, then automatically on first of every month your balance will be deducted, right? That's not going to be possible. Okay, even if you allow the bank to take money from your account, right? It is going to need a trigger. Someone has to press the button, right, in the smart contract. So that's always the case, correct? So those kind of things is not really the exact way you explain transfer from, right? So remember this example, and I think this is one of the best examples that you can get for ERC20 transfer from approve and allowance functions. Okay, so that is a misconception that you need to be aware of. Next comes the two events. This alone we haven't discussed yet, right? So as the event says, this is the transfer event. So whenever a transfer happens, right, you have to emit this event. Okay, it can either be the transfer function or the transfer from function. Both are going from one person to the other, right? So this has to be emitted. Second one is called as approval. So whenever you give approval to a delegate, you have to emit sender, delegate, and the number of tokens. So these two events has to be emitted, and this at the right point in time, right? So that's the one. One more thing you need to keep in mind is that ERC20 token does not say that these are the functions that you need to have. These are the only functions. No, this is not an exhaustive list. This is a minimal or mandatory things that you should have, right? Apart from this, you can have any functions that you want. You can create any variables you want, just to make sure everything is working fine and things like that, right? So that is the concept of ERC20. Now we are going to get into creating the body, creating the logic of each of the functions so that we understand it in more in depth, right? So let's start doing that. Great. So we'll go one by one to create the variables, create the functions, write the functions to simulate this ERC20 and create a working ERC20 token for ourselves. Okay. First, you can see that you have name, symbol, and decimals, right? So I want to get this from the user whenever he wants to create a new token. I want to get this from the user, and the best way to do that is using a constructor, right? So I'll add a constructor, right? This is gonna be okay. This is gonna be constructor, and this and public, and this is gonna get all the required things. So string memory underscore name, string memory underscore symbol, and uint 8, right, for decimals. So you will say uint 8 underscore decimals, right? So let me assign all of these. Name is equal to underscore name, symbol is equal to underscore symbol, right, and decimals, okay, decimals is equal to underscore decimals, right? It's not decimals, decimals. Okay, wonderful. So I've created a constructor. So whenever a new deployment is happening for this ERC20 token, I'll get all the details from the user and create the name, symbol, and decimals of my token. So this usually is 3 or 4 letters long. Okay, so you can see BTC, ETH, band, all of these things are 3 or 4 letters only, right? So we can also maintain the same thing, right? So I've created the first thing called as constructor to start this token with name, symbol, and decimals. Now we'll go into each of the functions and create variables whenever required and emit events whenever required, right? That we can do. The first thing is called as total supply. What is the use of it? Whenever we call this, it's going to return unsigned to integer 256 with the maximum supply. But do we have a place where we have stored the maximum supply? Not yet, right? So let's create a UN256, right, public, and let me just call it supply. Okay, so what I'm going to do is also get UN256 from the user while creating it and call this supply. Okay, so within here I'll say supply, right, supply is equal to underscore supply. Yeah, so the supply is done, which means this function is gonna be pretty easy for us, right? So here we are gonna just say return supply, correct? So that's the use of the supply itself. So total supply, I want to know, I'll just call this function and I'll get the supply, total supply, whatever is there in this contract. Okay, that's fine. Also you need to do one thing, right? When the constructor is called, okay, we need to allocate all the tokens created to the called person, right? Whenever I am creating a token, in the beginning I will own all the tokens, correct? That's the logic, how it should work itself. Yeah, otherwise there is no token, nobody has a token. Whom can you transfer to, whom can you get from? It's gonna be difficult, right? So now remember that you can do it however you want. The logic within this can be anything. Okay, think of it like an interface. In fact, ERC20 is an interface, correct? That gives you rules, but you can implement it however you want, right? So that's what we are doing here. You can name it supply, or you can name it total supply, anything you want. Yeah, that's not a problem. Now next comes balance of. Okay, which means if you give an address, it should give back how much tokens that person has. Okay, how can we do this? Yeah, how can we do this? How can we map an address to a balance, right? So in the same question we have the answer. We'll create a mapping for that. Okay, so here you will do a mapping, right, from what to what? From an address to an unsigned integer, because as you can see here, balance of returns an unsigned integer, right? The balance of a person cannot be negative in tokens, right? So here you will give unsigned integer, right? Call it public, and what can we call it? Balances, maybe balances of a person. Yeah, so this is gonna give me, right, this is gonna give me balances of the token owner, right? That's what we want. So here I can say return balances of the token owner. So this will return how much this address has, correct? Now tell me how much should the owner of the token have? The maximum amount, right? So that's why in constructor I want to do balances of the message.sender is equal to underscore supply, right? So the total supply, if I'm creating 1 million tokens, that's all gonna be in my account when I create it. Okay, that's the balances of message.sender equal to supply. Okay, this is done, and then comes transfer, right? Transfer is gonna do from receiver, I mean the sender, myself, the message.sender, to whichever address I give as receiver. How many tokens? The number of tokens. Okay, here what I'll do is I'll create this. Okay, so this transfer, let's think about it. How can I transfer money from the sender, right, message.sender, to the receiver, right, is by doing balances. Okay, so what I need to do here is to reduce the balances. This mapping is there, right? This mapping are called balances. I have to reduce from my map the amount that I have and add it to his address, map it to his address, right? That's the simplest thing that you can do in transfer. Okay, so I'll do balances of message.sender, okay, minus equal to number of tokens, correct? From my balance I'm reducing the number of tokens, and to the receiver, okay, receiver's balance, I am adding the number of tokens, correct? So that is how you take money from, or the tokens from your account, and give it to the receiver's account, right? But I need to also do a check here, which has to check if I have enough balance, right? If I have only 1000 tokens, I cannot send 2000 tokens to someone, right? So I need to check if balances of the message.sender is greater than or equal to, right? Balance of the message.sender is greater than or equal to the number of tokens requested. Okay, so only if I have more balance, I'll be able to transfer. Okay, so this is the one, and here we need to go back and look at the event. So there is a transfer event. I have to emit this event here. Okay, so here I'll say emit transfer, right? What all does the transfer event need? Sender, receiver, and tokens, right? Okay, let me do. Sender will be message.sender, receiver is receiver, and number of tokens is num tokens. So that's how I create this, and it returns a boolean also. Yeah, so let me return 2. Okay, so with this the transfer function completes. Okay, I'm just checking if he has enough balance, reducing the balance, increasing the balance, emitting the event, so we'll know the front end that it has been done, and return true because the statement said so, that way. So that is the transfer function. Okay, yeah, I think till now it has been going really well. Now we'll do the approval, allowance, and transfer from. Okay, now approval has to be like from my address. I can approve anyone, right? I can probably have 2 3 exchanges also. Let's say Binance, Coindex, or WazirX, any of these exchanges, right? And I can list my coins anywhere. I can give them anything. So I am thinking we need to create something like a double mapping, right, to do this stuff. You can do it in other ways also. There are multiple ways. It just says you have to approve the delegate to spend some tokens, right? I think this is the best way to go about it, and you'll also learn a new concept of how to do a mapping of a mapping. Okay, so let's do it that way itself, right? Or if you can think of any other thing, post it in the comments maybe, right? So I want to do a mapping, okay, which takes an address. This will be the owner address, okay, which also has a mapping inside. Okay, this has a mapping of address, okay, to event. So this will be the owner address, this will be the delegate address, and this will be this. So one owner can allocate or delegate to multiple delegates, okay, and each will have a particular allowance, right? So that's the concept of double mapping, right? So this is how you create mapping of address to event. Here also you have to give a mapping, because mapping is mapping to another mapping. Okay, so this concept you'll understand how to call this and things like that. So this is a public, and it will say allowances. Can we got an allowances, or allowance is good? Do we have an allowance? Yeah. Okay, they have we have a function called as allowance, so let's call it allowances, or let's say allowed. Okay, allowed will be better, right? So we'll call this allowed. Now I have to approve, right? So let's go to this and create the function here. I'm giving spaces because you can easily identify, and when you copy this, you'll be able to read easily, right? So now I have to approve the delegate to spend some tokens. So I'll say allowed, okay, of from the owner, right? Who is the owner? Message.sender. I am only going to allow, right? Who is the receiver or the delegate? It's delegate itself, coming from the argument. Okay, so this will be set to number of tokens, correct? So delegate number of tokens, message.sender. So message.sender allows the delegate to spend so many tokens. So this is how you access a double mapping and all. Okay, so that you remember. And then I think we have a approval event also, right? So I am approving someone, right? So I'll give the sender, delegate, and tokens here. So I have to do emit approval. Okay, again I'm telling you, this is not the only way in which you can do this. There are multiple ways, but this I think is by far the best, right? Who is the delegate and the number of tokens, correct? So with this it's done, and you have to return a boolean going by the standard, so we'll return true. Yeah, so that is how approve function is created, right? Wonderful. Now we'll go to the next function called as allowance. What does this allowance say? How much has the owner delegated to the or approved the delegate, okay, to spend. So which means if I call allowed message.sender delegate, it should give me the number of tokens, right? So let me just go here and create the function. Yeah, so here we will do return directly, right, allowed of the owner of the delegate, correct? Right, so this will return it. So allowed, it will go to the mapping owner first address, from that second address mapping, right, that will give the number of tokens that is allowed. So that's why it returns a unsigned integer, correct? So that is how this allowance works. Then we'll come to transfer from. Okay, transfer from, remember, is used by exchanges or the delegates to transfer this. Okay, so here what can we write is we need to check both whether the owner has enough balance and is the delegate allowed to spend so much, correct? So we'll just do the both the required things now. Require that the number of tokens is less than equal to, or will maintain the same thing. What is the required I wrote here? Yeah, this one. So I can say balances of message.sender greater than equal to number of tokens, right? First, the owner, the sender has to have enough tokens. Okay, next I'll do require, okay, this is will be a bit tricky, allowed of message.sender that has been delegated to the caller, right? Allowed of message.sender, no, it should be allowed of owner, correct? Because message.sender will be the exchange. I don't want to check the balance of exchange. I want to check the balance of the owner if he has enough money first. Then allowed of the owner. How much has the owner allocated the message.sender? So message.sender is the exchange, right? Be very careful when you write this. Think logically, right? Should be greater than equal to number of tokens. Okay, perfect. I think we have written both the required statements correctly the first time itself, right? Then we will do the normal process of transferring from the owner to the buyer. That will be exactly like this. Okay, you will take from owner and send to the receiver, right? So here message.sender is not the owner, no, it will be owner minus equal to number of tokens and balances of the buyer, balances of the buyer plus equal to tokens. Take from the owner and give to the buyer, correct? Wonderful. So because I have allowed it, it will be able to do it automatically. Also, you need to note that in this example that we saw, right, he has, this admin has 1000 allowance, okay, and first of that month, Amazon cash on delivery comes in, and he is paying $100 to Amazon, okay, which means for the rest of the month he has only 900 allowance. He has used $100 of his allowance already, okay. So whenever some transfer like this happens, right, you have to reduce the allowance also. So let me do that by saying allowed of owner, right, and message.sender. This is what I need to say. I mean, owner giving to Binance is minus equal to number of tokens also, right? Wonderful. Again, we have to emit this transfer function, right? We'll do it emit transfer and then say what all we need: sender, receiver and tokens, right? From the owner it goes to the buyer, number of tokens, right? So that's how I emit a transfer function from transfer from. And does it require a pool? Yeah, there's a boolean also. We'll say return true. Okay, so that is how you create an actual ERC20 token which works. Okay, so let me add the comments on top so it's easier for you. That's the usual way we do it, but since we saw the interface first, we'll just format it, in a way that we can read it whenever. And I'll tell you, this is one of the holistic tokens, and you can use it in the production level itself, right, to create a token. So all of it, name, symbol, decimal, supply is done, and mapping of balances, mapping of allowed, okay, transfer and approval we have emitted whenever required. And in fact, this you can say address, receiver, and tokens. Why not? You don't need underscore there anyway. Okay, constructor gets 4 things, and message.sender will be the person who will taking it. Yes, I think our ERC20 token is ready. Shall we put it to test? Please, right? Go to this, deploy, and I'll do it in JavaScript VM only, so the transactions are easier, right? While deploying, I have to give the name of all of these things, right? So I have to give a string for the name of the token. Let's call it blockchain token, because we are enthusiasts of blockchain. Symbol, we can call it blockchain, right? So BCN, let's say, okay. And decimals, let it be 2. I want to transfer 100.25 tokens to someone, but not 100.253 and things like that. I want to make it very simple, okay. And let me create a million tokens, and click on transact, right? So 7043 is going to have 1 million tokens now, right? So that's how simple it is to create tokens for ourselves. So how can we check how much balance this guy has? We can just copy, right? Just copy, go to balance off, right? Give this address, click on it. He has 1 million tokens, right? The constructor is working well, right? Let's check all of the functions if it is working well. So total supply is a million tokens. The symbol is BCN, supply is this, but this is a public variable, right? So it will create a function automatically anyway. Name is blockchain, that's fine. Decimals is 2, so everything works well, till now, the constructor. So total supply is the function that we just called. Total supply gives 1 million as expected, right? Balance off, we just checked. If we give an address and click on balance off, it's going to give the balance. Let me check for another address, right? Just copy this and go here, check for balance off. This guy has 0, right, as expected. Yeah, the owner has 1 million tokens. He has not given to anyone yet. Okay, that's what we are going to do and check. Now I want to transfer some tokens from myself to some other person. Okay, so the one which I just copied, AC27, copy this again just to be on the safe side, right? Go to this and you can transfer, right? So I'll give the receiver address and I'll give number of tokens. Let's transfer 1000 tokens just so we can easily see the difference, right? 1000 tokens, transact, and the required statements, none of it blocked it. Okay, so here I've not given any error statements. If you want, you can definitely give that. That's not an issue. I'll leave it to you, right? So now since it is done, let me go back to balance off and check the balance. Okay, the second address has 1000 tokens and the first address, okay, first address is this. Let's copy, go back to balance off and check his balance. He has 999k tokens, right? 1000 was transferred to the other person, right? So transfer function works really well. And is it emitting the transfer event? Let's just see, right? Is it emitting the event? We need to check everything if it works in the token, right? Yes, it is emitting transfer function with sender, receiver, and the number of tokens. Yeah, perfect. Now we'll approve an exchange to spend on our behalf, right? So I wanna approve, let's say this BB5, let it be the exchange, correct? So now if I go to approve, give the exchange address, and I'm telling the exchange, you can I am allowing you to spend 1000 tokens from my account to the other buyer, right? So just transact. Am I in this? No. I have to be in the owner account. Okay, 7043. Now I can allow this to happen. So transact. Once it is done, is it emitting a approval? Yep, approval is coming. Sender, delegate, and tokens. Correct. So that's how it is done. Now let me check the allowance. How much I have given. So if you go to allowance, right, you can give the owner address and the delegate address. Okay, this is the owner address. Delegate address, I have to take BB5, right? That's the token. That's the exchange. So give these two, and if you call it, it's gonna give 0. Why? Why? 7043 is the owner. Okay. 7043 is the owner, and BB5 is the this thing. So when I approved it, 7043 to 70. Oh, okay. I have done a mistake here. Both sender and delegate are 7043, right? Shouldn't let that happen. Probably we need to write a require statement for that also, right? So let me copy this and again approve it. Okay. Now it is BB5 and transact. Okay. Now if I call this again, it's going to give 10,000. Now I have allocated or delegated 10,000 tokens to the exchange. That happens when you copy multiple addresses and things. It's okay, right? So the exchange has been allowed. Now the last function called transfer from is what we need to check. So here it will be owner address, right? 7043. Just copy this. Okay. Owner to buyer. Okay, so let's say DDAF is the buyer. Okay, so DDAF is the buyer. I wanna transfer, let's say, 500 tokens. Okay, out of the 10,000 allowance I have, I wanna transfer this. So what I'm doing here is I'm not gonna call from 7043, right? But I'm going to call from my exchange account. What is my exchange account? BB5. That's the one that has been approved, right? So BB1 will call this transact, and that is going to transfer, right? Transfer, check the logs, 7043 to DDAF, right? 500 tokens. Yeah. Now check the allowed function, right? Allowance, yeah, check the allowance. You can see that 9,500 is the allowance. So I had 10,000 allowance, 500 I used, so 9,500 is the allowance. Balance of 7043 will now be 998,500 because 1000 was transferred before, 500 was transferred now, right? And balance of this also will check. DDAF, does he have 500 now? Yes, he has 500 tokens. That is how you can see that all of the transfer, allowance, approve, this transfer, balance of, total supply, everything works in my contract, right? Of course, you can keep improvising this contract, right? So shall I add some more statements to just improvise this? Constructor, supply, right? Let me give a maximum supply. People should not say I want 100 trillion tokens and things like that. So let me say require that underscore supply is capped at, right, is less than equal to a billion, right? That should do million, billion, right? So maximum is a billion that you can create. You can change it whenever you want, of course. So here I'll say maximum supply can only be a billion tokens. Okay, that will be the error statement. Then what else do I want? Total supply, anyone can call it, that's not a problem. Balance of, not an issue, we can check. Transferring, we need to check, another thing that require that the message dot sender not equal to receiver. You cannot say I want to transfer from my account to my own account, right? That's the mistake which we did while delegation. So I don't want it to happen. So I'll just say sender and receiver can't be the same, right? Wonderful. Now here I'll say not enough balance. That gives a good picture to the user also. And I have to approve. So here also the same thing. Require that the message.sender, who is the owner, not equal to delegate. Okay, and here I need to say sender and delegate can't be same, can't be the same. Okay, so this is a require statement which would have stopped us from doing that, right? And allowed is fine, and here transfer from, I'll do the same thing, right? So I'll do require that the owner and not equal to buyer. Okay, so now we'll say owner and buyer can't be the same. Yeah, here also I'll say not enough balance, and in this place I can say not enough allowance, right? Wonderful. So we have created some more security in our token also. So this is uh, becoming a better contract going by all of these security measures that we have taken, right? So with this, I'll complete this ERC20 token. Why I created this ERC20 token in hands-on and looked at all the functions in detail, explained this in theory, is because whenever you get a job in Solidity as a developer, ERC20 is something that you need to know by heart, right? Everyone expects you to know ERC20 because any startup that's there in the Ethereum world is going to create their own token and go for an ICO or things like that, right? So as a Solidity developer, you are expected to know each and everything what it does here in this ERC20, and you have to create this with utmost security. That's very important, right? So that's the reason why I spent so much time in creating this ERC20. Hope you enjoyed the session. Remember, ERC20 is a very important topic when it comes to Solidity. Do not forget this. Do not forget the example so that it stays in your mind for a long time, right? I'll share this code with you. You can see it whenever you want, right? Thanks a lot. We'll see you in the next video.